Okay, so 7-4 scientific notation, and I think I've managed to fix my microphone so that I'm not super quiet, and now I'm super loud, as I should be. So, scientific notation. First off, before we talk about scientific notation, standard form. So, standard form is just the normal way of writing numbers. So when I say 2, again, hopefully you see this little numeral. Well, if I'm writing, you see. Okay, give me a minute. Give me a minute. Technical difficulties. You see this in your head, right? That's a standard form, standard way of writing numbers. Again, if I say 200, you probably visualize this in your head, right? You don't visualize maybe like 100 plus 100 or TWOHUNDRED, right? Okay. Scientific notation is just a different way of writing numbers. Specifically, it's a compact way of writing really large or really small numbers using exponents or powers of 10, okay? Scientific notation is something we made up. The whole point of scientific notation is that it literally takes up less room on the paper. Because if you're multiplying really, really big numbers, like say for instance the distance from the Earth to the Sun, and then you're multiplying by some sort of number in light years or something, really, really big numbers take up a lot of room on the paper. So this is simply a compact way of writing those numbers. What do you need? So the way we write numbers in scientific notation is we have two parts. A is going to be our number between 1 and 10. So it needs to be greater than or equal to 1, but less than 10. These are absolute value bars because A can be negative, but that number needs to be between 1 and 10. And then we're going to have a times 10 to some power. So very easy to do. I'll explain it in a second. But again, A needs to be between 1 and 10. That's just a rule that we made up. And then depending on how many times we move the decimal, we're going to store that as an exponent. So here's how we do this. So first, let me maybe explain the technical way to do this, and then I'll do the kid way. So again, if you have like 5,000, another way to write 5,000 is 500 times 10. And then you could write the 500 as 50 times 10 times 10. And then, hey, you could write 50 as 5 times 10 times 10 times 10. This right here is 10 to the 3. Okay. Now, 5,000 is not a very big number, so you probably wouldn't do that for 5,000. But this number down here, right, what is this? This is 5 million, 5 billion, so this I think is 5 trillion, right? Very large number. And if we can write it like this in scientific notation, then it's much more compact. Okay. Now, the other way to do this is instead of literally writing out these times 10 times 10 times 10 is again, each one of our decimal places is just a times 10. So this one decimal place would represent a times 10. This is another one. This is another one. And I did that one twice. So 1, 2, 3. And that would be 5 times 10 to the 3. Okay. So here's what we're going to do. I have the steps in the notes if you actually want to write them out, but I think you'll get it from just watching my example. Again, scientific notation, we need a number between 1 and 10. So I'm going to move the decimal until I have a number between 1 and 10. Okay, so I'm moving the decimal until I have a number between 1 and 10. So right now, if I were to stop right here, I would have 5,280, 528, 52.8. If I drop it off right here, I have 5.28. So I'm going to write down 5.28. And then again, each one of these moves that I did with my decimal represents a times 10. So I moved the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So this would be times 10 to the 12. Okay, let's do another one real fast. Over here, again, I would drop off my decimal. I'm going to move it until I have a number between 1 and 10. So right here I would have like 10.3. Right here I have 1.03. So I'm going to write down negative 1.0304. And then again, I'm going to write down times 10. And I'm going to count how many times I moved the decimal, because each time I move the decimal represents a times 10. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we can also use scientific notation for writing really small numbers. This works pretty much the same way, except each one of these decimal moves is not a times 10, but actually a divide by 10. Again, the way that you could write divide by 10 as multiplication, because there's no division in scientific notation, is again like keep, change, flip. So if you think about changing this to times and then flipping the 10 to be 1/10. Okay, so each one of these decimal moves is you dividing by 10, which is the same thing as multiplying by 1/10. And then like if you were to count up how many you had here, so this would be like 1 over 10 to the 3, and the way you would write that is with a negative exponent. Okay, so when we have really small decimals, the process works the same. We still move the decimal until we have a number between 1 and 10, except we're going to use a negative exponent to represent that we were timesing by 1/10 instead of timesing by 10. So again, move the decimal until you have a number between 1 and 10. So I'm going to drop it off right here. Now I have 4.93, so I write down 4.93 times 10. How many times did I move the decimal? I moved it 1, 2, 3, 4, 5 times. But again, I wasn't actually multiplying by 10 to the 5 because that would make a number bigger. I was multiplying by 1/10, so I need to put that in negative there. Okay, one more example. Here I have negative 0.03. So again, I'm going to move this until I have a number between 1 and 10. So right here I'd have 0.3, which is too small. So I'll move it one more time and put it right here. That is going to give me negative 3 times 10. And I moved the decimal 2 times, so I'm going to put 2. But of course, these were timesing by 1/10 instead of 10. The other way that you can think of it, maybe the small trick, is that for small numbers, you should have a small exponent. So negative 2 is a small number, right? If you think of positives being larger, so large number, large exponent, small number, small exponent. That's how I kind of remember it. Okay, so that is switching numbers into scientific notation. Of course, we can go the other way too, where we can take scientific notation and convert it into standard form. The process is pretty much the same, but in reverse. So I will convert these three numbers real quick, then I'll pause the video. I think I'm going to split this into two videos, one for converting between the two forms, and then for one for multiplying and dividing. So again, 3.902 times 10 to the 9. This is a number in scientific notation because it has the two pieces. It has a number between 1 and 10 times 10 to some power. So again, this times 10 to the 9 would be, I'm multiplying this number by 10 9 times. Each one of those times in by 10 is going to move the decimal one time. So really what I'm going to do is I'm just going to take 3.902 and I'm going to move the decimal 9 times. I'm going to move it to the right because this should be making the number bigger. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where I would drop off the decimal. And in these little empty spots here where I don't have anything, I'm going to fill in zeros. I'm now just going to rewrite the number 3902. 1, 2, 3, 4, 5, 6 zeros. Okay, another one. Here I'm multiplying by 10 to the negative 8. So again, the difference here is your 10 to the negative 8 is really like multiplying by 1/10 8 times. And of course, multiplying by 1/10 is going to make a number smaller. So I need to move the decimal to make the number smaller, which would be to the left. So I move the decimal 8 times to the left. 1, 2, 3, 4, 5, 6, 7, 8. Drop it off. Report the kids that did the 6, 7 hand gesture while I counted that out. Fill in zeros in these little spots. I didn't have anything. And then I'm just going to write this number out again. So I have 0.0000000. How many do I have here? I have 7. And then 625. And then I should, not start a number with a decimal, so I'm going to put 0 there. Okay, one more. Here I have 3.2 times 10 to the 4. Again, 10 to the 4 would be multiplying by 10 4 times, which should make this number bigger. So I'm going to write down 3.2. I'm going to move the decimal 4 times, drop it off, fill in the zeros, rewrite the number 3, 2, 0, 0, 0. Okay, that is switching between scientific notation to scientific notation standard form and standard form to scientific notation. So again, over here, you need to move the decimal until you have a number between 1 and 10, and then the number of times you move the decimal ends up being the exponent on the 10. Over here, you do the process in reverse for converting scientific notation to standard form. You have your number, you write it down, you move the decimal that many times in the appropriate direction. There you go.